talked last time about simple meters, like this one, 2 blue M&Ms, 1, 2, 1 and 2, 1 and a, whoops, I didn't have enough in that beat. Okay, let's try it again. 1, 2, 1 and 2, 1 and a, 2E and a. A simple meter where the beats that are blue M&Ms are split into 2 even pieces or 4 smaller pieces. Let's practice rewriting this in a time signature, like 2/4 time, a duple simple meter. Okay, the beats are going to be quarter notes. The subdivisions beamed together are eighth notes. The super subdivisions, those will be 16th notes. Okay, and I've got 4 16th notes here. Those will be beamed together because they're inside beat 2. That is the same rhythm as the one printed out with M&Ms. Great. But now, let's see if we can aim for something different. We're going to talk about meters that are not subdivided into 2 even pieces. Instead, I'm going to take these 6 M&Ms, and first I'm going to say let's group them, all 6 of these, into groups of 3. We're talking about beats subdivided into 3 pieces. How many groups do I have? 2 groups. Well, okay, and a green M&M could replace 2 of those reds. I could replace these other reds, 2 of them, but I don't have anything yet that would replace all 3 in a group. So I've got these 6 subdivisions. I could regroup them, but that's not what we're doing. We're grouping them into 3s because we want subdivisions that are in 3s. I need a new note value, so it's time to turn to the peanut M&M. We're going to say that 3 reds equals 1 peanut M&M. So I can take away those 3 subdivisions and replace them with a single note value, a peanut M&M. That's the same as a beat. Now I have 2 beats, 1, 2, 1, 2. Inside each beat, there are the equivalent of 3 red subdivisions. So I can call this a duple meter and say, well, sure, the top number tells me how many, the bottom tells me what kind, 2 green M&Ms. Okay, it's some kind of duple meter. Look, I've got 2 measures worth. And I'm going to split one of those back into its 3 subdivisions. This is a duple compound meter. Compound meaning the beat can be put into 3 subdivisions. So I'm going to do that for this beat over here. And that will have a little bit different feeling. 1, 2, la, lay, 1, la, lay, 2. 1, 2, la, lay, 1, la, lay, 2. It has kind of a lilt to it. Compound meters feel lilty often. I can still use my regular green M&M and knock out 2 of those reds. I can do it over here as well. Okay, 1, 2, lay, 1, la, 2. 1, 2, lay, 1, la, 2. Notice, though, that there are still those subdivisions of 3 inside that meter. It's a compound meter for sure. It gives it a whole different feel. That's why I'm using a different counting system with la and lay. 1 la, lay, 2 la, lay. Now, let's take 9 subdivisions, 9 M&Ms, and group them so that there are 3 in each group. How many groups do I have? Well, I can replace them with green M&Ms and it will become apparent. 9 subdivisions grouped in groups of 3 end up with 3 groups. So there are going to be 3 beats in this meter. It's going to be a triple meter. Okay, there's the 3. 3 green M&Ms. One measure has 3 green M&M beats. 1, 2, 3. 1, 2, 3. And remember, I could take away the whole note value there and put those subdivisions back in. I can do it a couple times if I want to. Sure, why not? Mess with the final beat there. There are all the 9 subdivisions, and I've sort of kept their little groupings so that they show up as 1 la-lay, 2 la-lay, 3 la-lay. Remember, each group of 3 little subdivisions can be replaced by that longer note value that is the beat. Now, I'm going to make a second measure so we have more to count. Let's see here. All right. And here's a nice rhythm. 1, lay, 2, 3, la, lay. 1, 2, 3, la, lay. So that's a triple compound meter. Now, those 2 green big beat M&Ms, I need something that would take up the 6 of those reds. I need something to replace those 2 big beats. I'm going to use the, I'm going to use the brown M&M and say 1 brown equals 2 greens, 2 green peanut M&Ms. So now I have a note value that's longer than the green peanut M&M beat. 1, lay, 2, 3, la, lay, 1, 3, la, lay. Let's check that math. When we had 6 red M&Ms, we grouped them into groups of 3, we got 2 beats. 9 red M&Ms grouped into groups of 3, we got 3 beats. What if I had 12 red M&Ms? I would group them into groups of 3, and how many beats would I have? Yeah, 4. I would have a quadruple meter because I would have 4 beats. Okay, let's play with that. That's a lot of M&Ms. There they are. Okay. Group them in groups of 3. And indeed, look, if you weren't sure, 12 divided by 3 is 4. There are going to be 4 beats in this meter. Okay, 4 greens. Green peanut and M&Ms get the beat. All right, I can get rid of some of those red M&Ms. There's 1 beat. Here's the second beat. 3rd beat. And 4th beat. We're just ignoring that little bar line. It's not for this one. 1, 2, 3, 4. Now remember, I can put back any of those subdivisions that I want to. 1, 2, 3, la, lay, 4. Oh, here, how about this one? 1, la, lay, 2, 3, la, lay, 4. That's nice. I can get rid of 2 whole complete beats by using the brown M&M. 1, la, lay, 2, 3. I could go 1, 2, 3. That takes up those 4 beats that I need. Now, remember, when I grouped those M&Ms, I kept them grouped in groups of 3. I'm just reminding us that that's the essence of compound meters. So here's that time signature that we made before, 2 green. But how would we write this in real notation? That's going to be the trick. 2 green peanut M&Ms. I need a note value on the bottom there that's equal to 3 eighth notes. I don't know what note value that would be. In fact, there isn't a number that we can use for the bottom. So what I'm going to do now is show you how it works. We're going to use eighth notes for the subdivisions. I can at least write this out in note values. So I've got 6 eighth notes grouped in groups of 3. What are 3 eighth notes squished together into? They become a dotted quarter note. So the beat in this case is a dotted quarter beat. 2 dotted quarter beats. But what would that bottom number be? I can't put to dotted 4 or something, so that doesn't work. We're going to have to do something different. Instead, we're going to say the top number is how many subdivisions, and the bottom number tells us what kind. 6 subdivisions that are eighth notes. And then when we see a big top number like that, we know to divide it by 3. We get 2 beats that are dotted quarters. 6/16, okay? The eighth note beat, or the red M&M beat, is going to be 16th notes, each in groups of 3 16th notes. Squish 3 16th notes together into one note value. What do we get? A dotted eighth note. So the beat is the dotted eighth note, but the time signature tells us 6/16. 6 divided by 3 is 2 big beats. All right, let's explain it one more time. Let's take that 3 green M&M beat thing. That had 9 subdivisions in it. Remember, we can replace those subdivisions with a single beat rhythmic value. Okay, I can do it that way as well. A little substitution for some of our subdivisions. I still have the equivalent of 9 M&Ms here. 9 subdivisions in one measure. So let's write this out. Let's say that the red M&M is an eighth note again. Okay. How many red M&Ms did I have? 9 of them, and they are now eighth notes. 9, 8. I'm going to start replacing them with actual rhythmic values. 9 divided by 3 tells us there are 3 beats. Each beat is the note value squished together of 3 eighth notes, or a dotted quarter. 9, 8 has 3 beats that are dotted quarter note beats. 1, 2, la, lay, 3, lay. 1, 2, la, lay, 3, lay. If only I could write 3 dotted quarter note beats in a time signature, but I can't. So the next best thing is to write it with the subdivision showing up in that top number. Let's change the note values. Instead of the red M&Ms being eighth notes, let's let them be quarter notes. Okay. That would mean there are 9 red M&Ms. They are quarter notes. So anything that was a red M&M is a quarter. Anything that was a peanut M&M, what are 3 quarter notes put together? A dotted half. 1, 2, la, lay, 3, lay. That's the same sound as the one written in 9/8. It's just using different proportions. So let's recap what we have here. We have compound meters where the top number does not tell us how many beats. The top number tells us how many subdivisions. The bottom number of the time signature tells us what kind of note the subdivisions are. How do we know how many beats are in compound meters? Take the top number and divide it by 3. So compound meters will always have a top number that is divisible by 3. It would be a 6, a 9, a 12, even a 15. So we can call a compound meter duple if the top number is 6, like 6/8 or 6/16. There are 2 big beats in 6/8. 6 divided by 3 subdivisions is 2. There are 2 beats, duple, compound. A triple compound meter would have a 9 for the top number, like 9/8 or 9/4. A quadruple compound meter would have 12 for the top number. 12 divided by 3 gives us the 4 beats that says quadruple. So 12/16, 12/4, 12/8. So again, a simple meter the top number tells us how many beats, and the bottom number tells us what kind of note are those beats. But the compound meter, the top number tells us how many subdivisions. When you see a time signature like 6/8, don't count to 6. It's not 1, 2, 3, 4, 5, 6. It's 1, 2, 1 la-lay, 2 la-lay. The beats are bigger than the eighth note in the case of 6/8. The beats are the dotted quarter note. It takes a little getting used to, but once you do that, it's much easier to feel the musical impact of compound meters instead of counting every single one of those little subdivisions as a separate number word. Once you do that, the compound meters have quite a lovely lilt.